Okay, so for the last problem, we're going to have a boy that runs at a speed of 3.3 meters per second straight off the end of a diving board that is 3 meters above the water. How long is he airborne before he hits the water? And what is his horizontal distance that he travels while he's airborne? So let's first draw a picture of this. We have a diving board, and it is above some water. We have a little guy, he's right there. He is going to be, so you can see really quick, diving into the water here, okay? And we know that it is 3 meters from here to here, and we know that he is running at 3.3 meters per second to the right. And we need to find how far he travels from the diving board to where he lands in the water, and we need to find how long time. So first of all, we're going to then come over here and do our x's and our y's. And we have acceleration, velocity, time and distance, acceleration, velocity, time and distance. It's important to make sure you set up your paper this way every single time. This will save you a lot of hassle and stress as you're trying to figure out which equations to use. Okay, so acceleration along the x-axis. We don't ever have acceleration along the x-axis. We'll only have a constant speed. Okay, so that's going to be 0. Our velocity on the x-axis, going right or left, is 3.3 meters a second. We don't know our time, so we're going to be solving for that. And the distance along our x-axis we are looking for as well, so we're going to leave that blank as well. Right? Acceleration along our y-axis is going to be 9.8 meters per second squared. This should be a negative. You'll find that we will be canceling that out or converting back to a positive, so we can always leave it positive, or you can convert later, either way. All right, your velocity initial, you're going to be starting from this moment, right when you get off of this diving board, briefly right in the air, you'll be at 0 before gravity starts accelerating you down past that diving board, so your velocity initial will be 0. The time we're still looking for, we'll leave that in there. And then our distance, you'll notice that they use distance and height interchangeably now. The distance between here and here, the height of the diving board off the ground, was 3 meters. Okay, so now that we have everything all filled out here, we can then go ahead and start with, we'll have to use the y side first because we have one variable to solve for here, whereas we have 2 over here on the x-axis. So let's start over here with the y. We're going to use that position equation, distance equals, goodness, vi, there it is, vi t plus 1/2 acceleration times squared. Had a little brain fart there. All right, so your distance for the y, remember we're just looking at the y side right now, is going to be 3 meters equals velocity initial, we said is 0. We said time is, we don't know, okay, plus 1/2. Acceleration should be that negative 9.8 meters a second squared. And then time we don't know, so leave that there. Okay, let's also say that the distance that he's going to be traveling is going to be down. So we're going to make that a -3. You can do this, again, this will turn your numbers positive, or you can just leave 9.8 as positive and your distance is positive and it'll be okay. But he is traveling downwards, so that is a negative distance that he will be traveling. And gravity always accelerates you downward towards the earth, so that is a negative 9.8. Either way is fine. All right, so let's simplify. We have -3 meters is equal to negative 4.9 t squared, right? And so we'll divide by that negative 4.9. You'll see here we'll go back to the positives, negative 4.9, and you get 0.6 equals t squared. We're not done, we got a square root, and you get 0.78 or 0.8, either way, is equal to t. So those are your seconds, 0.78. Notice how we're positive now, 0.78. Okay, and then now we just have our distance to solve for over here. And so we will do that right underneath here. Velocity equals distance divided by time. That's your equation. You always start writing with your equation and then you start plugging in. So you know exactly where you started it and where you're going. All right, so our velocity for the x-axis is 3.3 meters per second is equal to distance, we don't know. Time is 0.78. You want to cancel that out, so you're going to times by that 0.78 times by 0.78, and your distance you will get as about 2.6 meters. Okay, and so that'll be here, 2.6 meters. All right, and hopefully you understand how to do all that. I'll be back in class later this week, so if you have questions, you can go ahead and ask me.